In this video, we're going to look at how to determine the number of complex roots without solving the equation. A lot of higher degree equations are difficult to solve. So if you can solve the equation easily, we can go ahead and do that and to determine how many positive roots, how many negative roots, and how many imaginary roots. But a lot of equations are difficult to solve. So we're trying to use Descartes' rule of signs without solving the equation and try to determine how many roots and how many positive roots, negative roots, or imaginary roots. So first rule we talked about in the previous video was any equation. For example, like this one, we have the highest power of x is 3, so we call this equation is an equation with degree 3. And we will know by rule number 1, this equation must have 3 roots. So that's the first conclusion. But out of these 3 roots, some of them may be positive, some of them may be negative, and some of them may be imaginary. So how do we determine that? And first of all, we check the sign changes of the coefficients, and that can determine how many positive roots. So for example, we did before, we have positive, negative, positive. So there will be 2 sign changes, and that goes from between from positive to negative, that's 1 sign change. From negative to positive, that's another sign change. So because we have 2 sign changes, so there are 2 positive roots or 0 positive roots, because we cannot say for certain exactly how many positive roots we have. We can only say maybe there are 2, maybe there are 0, because the number of positive roots by Descartes' rule, it says the number of equals the number of sign changes or to this number decreased by a positive integer. So when you have 2 sign changes, you may have at most 2 positive roots or subtracted by 2. And so you have either 2 or subtracted by 2, you get 0. You cannot continue, because if you subtract another 2, you get negative 2. We cannot say an equation has negative 2 number of roots, so that doesn't make sense. That's why we only have 2 possibilities. So either either 2 positive roots or 0 positive roots. And to determine negative number of roots, we explained before, we replace the variable x with negative x, because when negative x is positive, x will be negative. So after we replace it, notice that we get this equation and check the sign changes. There's only 1 sign change. So which tells us this new equation has either one positive root, because 1, if we subtract by 2, then you get negative 1, which does not make sense. We cannot have negative number of roots, so that's why we only have 1 possibility. We must have 1 positive root. And if this new equation has 1 positive root, it corresponds to x, which is a negative root, because when the solution of this is x, solution of this, you get negative x. X corresponds to negative x. So when negative x is positive, and x will be negative. So that tells us this equation has, so let me write it over here. So x cubed plus x squared minus x plus 2. We already know it has 3 roots in total. And we also know it has either 2 positive root or 0 positive root, which means no positive root at all. And we have also by replacing x with negative x, we find out that this has 1 root. Okay, now let's check if, because there are 2 possibilities right here, so it really depends. how many solutions, how many imaginary it has. If the equation has 2 positive roots and 1 negative root, 2 positive and 1 negative, altogether you have 3 roots. That's all. And there will be no imaginary root at all. So I'm going to write down the conclusion for imaginary. No imaginary root. When, you don't have to specify that, but I can write down why here for you. So if the equation has 2 positive roots and 0 and 1 negative root, because we have altogether 3 roots, and we only have 3 roots, 2 positive, 1 negative, then you will not have any imaginary root. But what if it has 0 positive root? If it has 0 positive root and 1 negative, that means we have 2 imaginary roots. The reason is because we have total 3 minus 0 positive root and 1 negative root. That would tell us we have 2 roots left. What are they? They have to be imaginary, because any root, you only have 3 categories. Either it's a positive number, positive root, or it's a negative root, or the leftover, all the roots left will be, if it's not positive, it's not imaginary, it has to be, if it's not positive, not negative, then it has to be imaginary. So that's how we know, how we decide the number of imaginary roots. Just subtract the number of positive and negative from the total number of roots. So in this case, it's total number of roots 3 minus 2 positive minus 1 negative. You are left with 0 imaginary.